Your pods are healthy, containers are running, deployment succeeded, but your application is completely broken. Frontend cannot connect to backend. Backend cannot find its database. Microservices suddenly stopped talking. And the dangerous part is, Kubernetes looks perfectly healthy. No crash, no restart, no pending pods. But the real problem is DNS and service discovery inside Kubernetes are broken. Hi, I'm Shivam and this is the fourth video of Kubernetes Debugging Series. Today I will show you how Kubernetes DNS actually works and why healthy looking applications still fail in production. So, in my last video, we saw Kubernetes refuse to schedule pods. But today's problem is even harder because now pods are healthy, containers are healthy, services exist, but communication still fails. And this is where Kubernetes networking becomes dangerous because applications inside Kubernetes usually communicate using service names and Kubernetes resolves those names internally using DNS. If DNS or service discovery breaks, pod-to-pod communication fails, applications silently fails, and production debugging becomes painful. Let's break this step by step on my local kind cluster. Before we get started, I have one small request. If you have been finding these videos helpful, I would really appreciate you subscribing to my channel. It's a simple way to support my work and it encourages me to keep creating more contents like this. Now let's jump onto the video. So this is my cluster. I have one control plane node and two worker nodes. Let's create a file called backend.yaml. I have already written the contents of backend.yaml. Let me copy that and we will go over it one by one. As we can see, I have two components. One is deployment, another one is service. So let's go over deployment. The name of the deployment is backend app. It has one replica and it is running an Nginx image. The second type of resource is a service. The name of the service is backend service. It is running on port 80 and this target port belongs to this container port whose name is backend. So let's go ahead. We will apply this. It says our deployment and service has been created. Let's check them. Yes, our backend app is running and our service is also up. Now we have a backend application and Kubernetes created an internal service for stable communication. Now let's understand this clearly. Pods are temporary. Their IP addresses changes constantly. So application should never depend directly on pods' IP addresses. Instead, Kubernetes provide services which give stable networking, stable DNS name, and internal load balancing. Now let's simulate another application trying to connect to backend. Let me open another terminal of Git Bash. I'm gonna run a temporary pod named frontend app using imperative commands. Let's wait for the pod to be up and running. Okay, our pod is up and running and we are inside our pod. This gives us a temporary shell inside our cluster. Now let's try to simulate the first DNS failure. I'm gonna try to access our backend service using wget command. Let's wait for a few seconds. And we get an error saying it's a bad address. This is the most basic DNS failure. Here, the service name is wrong. Let's verify it using NSLOOKUP also. As we can see, it clearly says server cannot find backend service in my local cluster. So here, our DNS resolution failed because we provided the wrong service name. Let me clear this and we will try to access our service using correct service name. So earlier, our service name was wrong because I missed the last E in the service name. It was like this. Now I am using the correct service name and I am hoping to see the welcome page of Nginx. Great. I can see welcome to Nginx page. So this means our DNS resolution worked correctly and the communication was established. So here are some basic DNS explanation. Inside Kubernetes, service automatically gets a DNS name. So applications usually communicate using something like this, HTTP and the service name. So in our case, it should be http colon backend service. Very simple, very common, and yes, tiny mistakes can break communication instantly. But real production failures are usually not this obvious. In production, application often uses correct DNS names, but communication still fails. And that's where debugging becomes much harder. Now let's simulate a realistic production deployment change. Let me delete our old backend service. It says our service has been deleted. Let's verify that. Great, our service is now deleted. Let me create another file called backendv2.yaml. As we can see, the kind is service, the name of the service is backend API, and it is running on port 80. Very simple, nothing fancy. I'm gonna save it. Now, if frontend DNS still tries to access the old service, it will fail. Let's verify that. We can clearly see it says bad address backend service. This means that our DNS resolution failed and there could not be any communication that could be established. So what actually happened here? Imagine there is a team of couple of DevOps engineer and one of your engineer recreated the service with another name. However, the other engineers were not notified and those engineers are still trying to access the service using old name. This is exactly what production failures look like. Pods are healthy, containers are healthy, even backends are healthy, but communication is still broken. Now let's try to investigate this properly like a DevOps engineer. First, we're gonna check our pods. Our pod is clearly up and running. Similarly, let's check our service. So we have our backend API service which I created a couple of seconds ago using backendv2.yaml file is also there. But as we saw, when we tried to access this service, the DNS resolution failed because frontend still uses old DNS name. This is very common in stale configs or old environment variables, even in Helm upgrades or microservice migrations. But Kubernetes networking gets even trickier. What if the service name is correct, but Kubernetes still cannot resolve it? That's where namespaces becomes important. Let me clear the screen. I'm gonna create a namespace called production using imperative command. So what I'm doing here is I'm running a kubectl create namespace command to create a namespace called production. It says our namespace has been created. Let's verify it once. And we can see our production namespace is created and active 6 seconds ago. Let me clear this. Now I'm gonna create another file called backendprod.yaml. I have already written the configuration for backendprod.yaml file. Let me copy that and we will go over it one by one. So as we can see, there are two resources. First one is deployment, second one is service. So the name of the deployment is backend app. It is running one replica and it is using an Nginx image. Similarly, the second resource is service. The name of the service is backend API and it is running on port 80. Let me save this and we will apply our backend prod.yaml file. It says our deployment and service has been created. Now let's try to access this application using our front-end app. I'm gonna again run wget command with our service name backend API. As we can see, the DNS resolution failed again. Now the confusion becomes real. If I try to check the service, we can clearly see that our backend API service exists, but frontend still cannot resolve it. Now this is very important. Inside Kubernetes, short DNS names only works inside the same namespace. Let me remind you that our frontend app is running in default namespace, but our backend service, which is backend API, exists in production namespace. So Kubernetes cannot resolve that short name automatically. Inside Kubernetes, every service gets a DNS record. Let me clear this and I will show you the exact format. So again, every service gets a DNS record in format service.namespace.svc.cluster.local. So in our case, if we have to access backend API service in production namespace, we will have to use backend API.production.svc.cluster.local, basically in this format. Now let's try to test this using fully qualified domain name from our front-end app. I'm going to use nslookup command with fqdn. And this time it's successful and our communication works again. So now DNS resolution works, but here's the scary part. If DNS works perfectly but traffic still fails, that's where Kubernetes networking becomes really confusing. Let me create another file called brokenservice.yaml. I have already written the contents of this file. Let me copy that and we will go over it one by one. As we can see, the kind is service, the name of the service is broken service, and it is running on port 80. Let's save this and we're gonna apply this file. So our service has been created. Let's verify it once, and broken service is up in default namespace. Now let's head back to our front-end app and we will try to access this application using nslookup. As we can see, it is working. Ignore this NX domain. We only have to look at the server address and this name. It says the name and the address. So our communication was successful. Now if I try to run command wget using HTTP service name, that should also work. So we got a connection failure. Why? So this is one of the most confusing Kubernetes failure. DNS works, service exists, but traffic still fails, even though our nslookup worked perfectly. Now let's try to investigate this deeper. Let me run a describe command on our service called broken service. If you see here, the selector, it says app equal to backend v2. However, our pods are using selector as backend. Let's verify it. I'm going to again open a git bash. If we try to do a cat on our backend.yaml, we can clearly see the selector here is app equal to backend instead of app equal to backend v2. So this is another important concept to keep in mind. So how pods and services communicate with each other. They use labels and selector to communicate. So whatever label is defined in our deployment or pod, it should exactly match in the selector section of our service. Now if we try to do a cat on our broken service, we can clearly see that the selector here is app equal to backend-v2 instead of app equal to backend. So this is the reason why our communication is failing. Now another way to verify this is by running kubectl get endpoints. We can clearly see the backend service does not have any endpoints. So the service exists, the DNS exists, but no pods are attached behind the service. This is a real production debugging. So let's try to update our broken service.yaml file and we will verify our endpoints once again. I'm gonna update the selector to backend. I'm gonna save it and I'm gonna reapply this file. It says our service has been replaced. Let's do a describe on our service, and this time we have our correct selector. Let's try to get endpoints also. We can see some IP address here. I am hoping this IP address belongs to our backend pod. Let's verify it again. So we can see that our IP address clearly matches with our backend app. It says 10.244.1.18, which is exactly here. Now let's understand who resolves these DNS names. Inside Kubernetes, a DNS server runs inside the cluster. It is usually called CoreDNS. Let me clear my screen and I'm gonna run kubectl get pods command in kube system namespace. As we can see here, I have two pods running for CoreDNS. So CoreDNS powers Kubernetes service discovery. Whenever pods resolve service name, request first goes to CoreDNS, then CoreDNS checks Kubernetes service record, and finally it returns cluster IP. So let's go inside our frontend pod. Let me clear this, and I'm gonna run cat etcresolve.conf command. As we can see, it clearly resolves to our name server. This is the internal Kubernetes DNS server. These are some tiny details, but comes very handy when we are doing a production debugging. So in production, DNS and service discovery failures are extremely dangerous because pods look healthy, container keeps running, and deployment succeeds, but application silently fails and debugging becomes confusing. Application often logs vague errors like host not found, temporary failures in name resolution, or connection refused. But the real issue may be wrong DNS or wrong namespace or broken service selector, even no endpoints or stale configurations. So now you understand something critical. Kubernetes networking is not just about running pods. DNS must resolve correctly, service must exist, namespace matters, selector must match pods, and endpoint must exist. Your application may look healthy, but if service discovery breaks, your system still goes down. So now you have seen what happens when application cannot find each other inside Kubernetes. But here is another dangerous production problem. What if your application does receive configurations but keep using old values? You update a config map, everything looks successful, but application still behaves exactly the same. No crash, no errors, no failures. Your application is running with stale configurations. And this confuses lots of engineers. In the next video, I will show you how config map actually works, why configuration changes doesn't always update running applications, and the critical difference between mounted configs and environment variables. That's where Kubernetes configuration management becomes really important. I will see you in the next one. Till then, keep learning.